This video explains the concept of balanced sections. Take the typical beam cross sections D by D. Now the reinforcement at a distance of small d. So if the strain distribution is drawn here, which is 0.03 concrete strain, and yield strain is 0.025, the calculation is given here for 500 gauge. Just the calculation of ESY is yield strength over Young modulus. Young modulus of the steel is 200,000, give us 0.025. So if we use a similar triangle, for example this triangle and this small triangle here, we are talking about these two triangle here. Let's say this red triangle here, this triangle. Now this triangle has a this value 0.03 divided by dn. This value is dn equal to this small triangle here. This small triangle here, it has 0.025 here, and this distance can be found by d. Take away dn, so that distance is d minus dn. Now if you move this one across, bring this one here, d over dn minus 1, simplification gives 0.83. d on dn is, bring this one across, become 1.83, inverse minus 1. So this can be calculated by just taking this one, because we are just swapping this d over dn over d. So dn is become 0.5 d, and this value we can just make it as a ku. Now in this case you can see that the depth of the neutral axis is almost half of the depth. So we are just taking the neutral axis in the middle. So if you have let's say this is 500 millimeter depth, then the neutral axis is almost 250 millimeters. So that is the balance sections, is almost in the middle. Now this concept which is called balance section, where your dn is 0.5 d, is not permitted in the beam because it's not ductile. Because you can see this is not ductile, because we have many concrete contribution. This is all the concrete that we are taking into account in the design. So this is not this is very brittle behavior. In that case, to ensure that the section is ductile, so we make sure that the section is ductile. It should not have a brittle failure. The depth of the neutral axis should not exceed 0.36 d. So for example, we make sure always dn value that we calculated is always less than 0.36 depth of this one. Now for example, this is balance sections where we have this value is just a half of d. Now here this is not allowed, because this balance section is not allowed. But what we need to shift this neutral axis, so that we just get the concrete only this portion, not this whole portion. So how much d we need, how much dn we need? Dn is generally allowed is 0.36. so whatever the depth is times by 0.36, that's the depth of the neutral axis. How do we shift? Because you can see this neutral axis is here in the balance sections. We need to shift this neutral axis above by increasing the number of reinforcement. For example, here we have 3 reinforcement, we can make it here 4 reinforcement, and so on. That will increase that will push this neutral axis above, and that will increase the AST. So this requirement is maintained by increasing the reinforcement. As I mentioned, since we put more reinforcement here, that will shift the neutral axis above. That will satisfy the conditions. Now to calculate the AST, sometimes we ask to calculate the AST, so we need to check this condition. This will be used later to develop an equation for the maximum AST allowed in a beam section to satisfy this requirement. This requirement means this requirement. So when we calculate AST, we make sure that our dn value is less than 0.36 d. This is the concept of balance section. Thank you.